In this lesson we're going to look at the magnetic force and find out what produces the magnetic force. So before we do that, we'll just have a quick review of the electrostatic force. And as the word suggests, the electrostatic force is a force between static charges, that's to say charges which are not moving necessarily. So it's the interaction between stationary charges, and there's a fun demonstration of this which you can see in the practical demo section, where you charge, for example, two straws with negative charge by rubbing them against your hair. Okay, so electrons jump from your hair onto the plastic straws, and then you can demonstrate that these two straws really easily repel each other. So charges can be both negative and positive, and they will interact with each other in different ways. If the charges are opposite charges, then they will attract. If the charges are like charges, negative, negative, or positive, positive, then they will repel, as this simple experiment demonstrates. Okay, so two types of charge, positive, negative, and two types of interaction, attracting and repelling. Okay, so why talk about the electrostatic force if we're talking about magnetism? Well, the reason for that is because they're both really intimately related. The electrostatic force involves a force between stationary charges. The magnetic force is produced whenever charges move. Okay, so that's the key difference. Whenever you get a negative charge or a positive charge to move, for example in the form of an electric current, then a magnetic force will be generated. And so this force will be manifested in the two areas that we're going to be looking at in this unit. And those two important areas of magnetism deal with, first of all, permanent magnets and then electromagnets. And though they might appear to be radically different in nature, in fact they're produced by exactly the same effect. So for example, in a permanent magnet or in a magnetic material, you've got electrons which are moving in an orbit and spinning in the individual atoms that make up that material. So it's precisely this movement of electrons which is, quite a complicated business, and we're not going to go into too much detail in that, but it's the movement of these electrons which produce the magnetic field. Okay, we'll look at permanent magnets a bit more closely in the following lessons. This is just a brief review. And the other type of magnet which you're going to come across, which is electromagnets, well, that's also produced by electrons which are moving in the form of an electric current, perhaps through a single straight wire or through a solenoid like this, and that will generate a magnetic field and a magnetic force. So you've got electrons flowing in a current, for example, through a conductor. Now, both of these electron movements produce effectively what is called a magnetic field. We will look at magnetic fields as well, and so these magnetic fields in this case are represented by these field lines. And the magnetic field, just like the electric field, which is produced by charges, or like the gravitational field, which is produced by masses, result in interactive forces. So we'll look at how these magnetic fields interact with each other in the following lesson. All we're going to do now is say that just as the electrostatic force can be both attracting and repelling, the same applies to the magnetic force. Okay, so whereas we had positive and negative charges, when we're talking about magnetism, we refer to the poles of a magnet. Okay, so the poles are identified as either North Pole or a South Pole, and typically in the type of school laboratories that you might use, these are normally painted, for example, red and blue. So red is always north and south is typically blue or white. So these poles are always at either end of the magnet, and they will interact with each other. If the poles are opposite, either north-south or south-north, then that will produce an attracting force. And if the poles are the same, that is south-south or north-north, then that will produce a repelling force. Okay, and as I mentioned earlier, these forces actually originate from interactions between the magnetic field lines, which I haven't drawn here, but we'll look at that in the next lesson.